Hi, welcome to the Red Hat on Red Hat virtual session on IT brokering, automating the path to production. Today we're going to cover Red Hat IT's program centered around simplifying the business requirements process for application deployment. Before we get into the main content, I'd like to call out the Red Hat on Red Hat program, where we promote Red Hat's usage of Red Hat products to solve IT challenges. If you'd like to find out more, you can follow the link at the bottom of the slide there, redhat.com/redhat-on-redhat. What we'll be covering today, we're going to start with introductions for the speakers, and then we're going to hop into the backstory, effectively the problem we were trying to solve with IT brokering and how we were thinking about isolating the problem of business requirements navigation versus how we realize those requirements once they were found. We'll talk a little bit about, again, splitting out the two sections there, focusing on how we improved the business process automation around application requirements for deployment. And then we're going to look into our Center of Excellence programs and that utilize operator automation on OpenShift to realize the requirements for application deployment. And at the very end, we're going to talk about some of the lessons learned as part of this program. So I'd like to introduce the speakers, and I'll start with myself, Ben Pritchett. I'm the IT Platform as a Service tech lead for Red Hat IT. And what we do within the IT PaaS team is effectively offer container platform services, mainly OpenShift, as an IT service. And at this point, I'll hand it off to Tom.
Hi, I'm Tom Benninger, and I'm a senior architect on IT's application lifecycle management team. We help our application teams develop software better, faster, cheaper, and more securely by providing both tools to developers and patterns to help them accomplish their goals. And I'll hand it off to Ryan.
I'm Ryan Wilson. I'm a digital business consultant on the IT Enterprise Architect team, and my role is to help teams get their projects off the ground faster. Before we start talking about brokering and operators, I want to give you some context about what was going on in Red Hat IT that led us down this path. Red Hat IT hosts several hundred business applications, and we add to our portfolio every month. Over the last couple of years, we've decided to standardize our application hosting on what we call the managed platform. The managed platform is a hybrid cloud platform that's built on top of OpenShift, running across multiple AWS regions and data center sites. And if you actually want to learn more about this, I suggest that you look up Tom and Ben's talk from Summit last year, and you'll find those recordings online. About a year ago, we had about a quarter of our applications running in the managed platform, but our goal was to get to 2/3 of our legacy apps into the platform so that we could make it the default location for all new applications. Onboarding applications to the managed platform was seen to be somewhat faster than onboarding to legacy hosting. But to hit our goal, we knew we needed to optimize the onboarding process even more. And this is where I came in. Last year, I was asked to lead a team that was focused on helping our stakeholders get their applications into production. As we started to dive into this, we were hearing a lot of negative things from our stakeholders and from our own teams within IT. From our stakeholders, we were hearing things like, why didn't anyone tell me I needed to do A, B, or C? Or I don't even know where to start. And from within IT, we were hearing things like, how did that get into our pipeline? Or I don't know what to do with this. Or even worse, I don't have anyone to take on that work. As you can see, our current process was causing a lot of frustrations on all sides. After completing several engagements across 8 different business areas, we recognized a consistent problem. And this was occurring whether they were new to IT or a repeat stakeholder of IT. The problem that everyone encountered is that they did not know how to navigate IT's business processes. And this was making our stakeholders feel like they had to piece together emerging requirements or feel that they have to re-engineer their solutions to meet our requirements. As I was engaging with app owners, I was learning what they needed, and I was gathering all of this information into one place. And we actually ended up with a document that we called Steps to Prod. But it was 12 pages long. I mean, if I had just handed that to anyone and said, okay, just follow this 12-page guide and you'll be good to go, they would have screamed at me. But now that I had this tool, when I was talking to app owners, I found myself just copying and pasting what they needed and making them a custom Steps to Prod doc. And this was actually working out well. But of course, this had its own set of problems, like maintainability and scalability. So obviously this was not going to be the end result. And then I ran into Tom and Ben. I shared with them what I was dealing with and how I was approaching the situation. And through several conversations, we actually realized that we had two problems. First, a business problem. Folks just didn't understand IT business processes. And the second was a technical problem. Once you navigated IT's business process, how did you actually go about getting your technology provisioned? So now we all agreed that we had a new goal, and that was to provide a predictable path to production. So now that we knew we had two problems, we decided to break this up into two work streams. The first being brokering, and the second being Center of Excellence for Operators. The key outcome for the brokering function was to ensure that application owners are able to navigate IT's business processes in a predictable and efficient manner. And for the Center of Excellence for Operators, the key outcome was to ensure we had a catalog of certified and supported application components which could be quickly deployed in an automated fashion. For both work streams, we decided to go through an iterative process. In each phase of work, we broke a problem down, solved it, and then moved on to the next, starting with brokering and wrapping it up with our Center of Excellence for Operators. Now I'm going to hand this off to Tom so he can go into more details about all the iterative processes we took for this POC.
Thanks, Ryan. Let's dive into brokering and business process automation. As Ryan mentioned, we had two core problems. How do we get through the business process, and how do we do the technical implementation? But that means we actually had a third problem, which is how do we connect the business processes to the technical implementation? What's the magic glue that allows a solution to flow seamlessly through both? We're going to talk about all of these problems in order. So let's start with where we started the project. We started with the Steps to Prod document. As Ryan mentioned, it itself was a long document, but it included 24 complicated security requirements, references to 17 other sets of technical documentation, call-outs to 9 other processes that need to be executed, and 16 individual tasks that needed to be done as well. And at the end of this, you had just solved the business problem. You hadn't actually gotten something ready to deploy in production. Reviewing these, we found that the processes were often complicated. Some processes would affect the outcomes of other processes. Some of them needed to be executed sequentially to be done correctly, and that the requirements didn't always apply to every type of application. Specifically, many of the processes and requirements didn't apply to applications being deployed in the managed platform, which was our primary focus. This led us to our first hypothesis, that we could filter out unnecessary parts of the Steps to Prod document. By asking a set of simple questions and implementing some simple business logic, we could actually give the application teams exactly what they needed to do to get through the business processes. With that idea, we came up with a list of simple questions, very high level, that we could ask any application team. Is your application internal or internet facing? Who uses it? How critical is it? What sort of data does it use? And what type of application is it? Things like that. From that, we could build some simple business logic. Here we have an example of those questions, some answers that we put in, and then a summary of how that affects the Steps to Prod. You can see of all of the requirements and processes, based on the answers on the left, 15 of them were either automatically passed or completed, 3 needed to be verified, and there were some specific actions the team did need to do. There were 3 processes they need to execute, 9 design requirements put on the team, and 4 application lifecycle requirements put on the team. But we've gone from pages and pages of documentation, including requirements and processes that teams don't need to execute, to a precise number of processes and requirements they do need to deal with. With that, we can also generate precise feedback, telling them exactly what state each of the processes and requirements is in, and providing them details on how to complete just those parts. So here you can see, based on those questions, the team would not need to fill out the CMDB intake, but would need to do an architectural assessment. They would not need to worry about operating system hardening because they're running an OpenShift, but they would need to worry about secure key management. This provides us a fairly good proof of concept solution for the business processes, but leaves us without solutions for the technical problems or the glue between them. This brought us to our second hypothesis. We could actually begin to generate those application configurations based on data we collected. Extending the data we collected to include functional implementation details allows us to do this. Here you can see we asked for the OpenShift project to install the application into, the name of the application, what Git space it lives under, and things like application codes that allow us to tie it back to our CMDB. With this additional data, we can actually generate a YAML file that can be used to build and deploy the application in the managed platform, thanks to the OpenShift automation. Now we have the second middle problem solved. We have an okay solution to get through the business problems, and we have a way to hand off to the technical problems. This led us to our third hypothesis. Can we make the business process part of the solution even better? Can we increase the usability and scalability? The work we have been doing with the proof of concept was kept in a spreadsheet, and managing applications through spreadsheets isn't efficient or scalable, and we couldn't keep it up to date. If a new requirement was added, all of the old spreadsheets would have to be updated manually, which just wasn't feasible. So we transferred all of the business logic into a simple web application. This web application asked the same questions and generated the same type of output, but because it was being kept in an application, we could ensure that all of the recommendations and all of the business logic was centrally managed and updated and tracked through a revision control system. Additionally, we could put better feedback in terms of easier to read user experience in the application. Now we had a pretty solid solution for the business process problems, and we called it our Pathfinder pilot, and we had a pretty solid solution for how we handed this off for the technical deployment through OpenShift YAML. And with that, I'm going to hand it back to Ben so he can discuss how we used the Center of Excellence in Operators to do deployment.
Thanks, Tom. We've gone through the new process used to navigate our IT requirements for application deployment and hosting. And as Tom mentioned, we've ended up with a holistic definition of what the application should look like, what it should implement to realize those requirements. But again, as Tom mentioned, there's a process to how do we go about realizing these requirements for the app team. And before we talk more about that solution, I'd like to set the context for our managed platform service, as Ryan mentioned earlier. This is our IT service based off OpenShift Container Platform. And what we've noticed over the years that we've offered the managed platform service is that it's very easy for application teams to get in and deploy containers. That's effectively the main thing that OpenShift Container Platform does. But there's a lot more that kind of goes into setting up an enterprise application. You have certificates to manage. Generally, for more of a stateful application, you have a database to connect to. You have a Git repo that you generally manage the code for the application. You have storage. sometimes you'll have to manage firewalls as part of your application. And we noticed that when applications deployed to the managed platform, there was still a lot more that they had to go out and do that sometimes was confusing or unclear about how they went and met these requirements for their application deployment. There were three main issues we saw with this, that requirements would be realized in sometimes non-standard ways. We'd see applications solving for the same challenge, kind of using different solutions. So we wanted to see how we could standardize there. Often the realization of requirements was confusing or unclear, like I mentioned earlier. It wasn't obvious how maybe you manage a network firewall when you're deploying to OpenShift Container Platform. And the third thing is sometimes requirements wouldn't be met at all. And this obviously is an issue that we'd like to make sure all of our applications are meeting the necessary enterprise requirements that we expect. So we took a step back and asked ourselves, where is the OpenShift product going? What is it doing? And at the time we were kind of doing this investigation, sort of been early 2019, we noticed that this is around the time that OpenShift 4 was coming out, and there was a large re-architecture of the product to this operator model of managing stateful applications. We noticed, as you go down the utility services of OpenShift, and even looking at how broker services are being changed in OpenShift 4, there's very much a utilization of the operator concept. And so we wanted to look at how this may be used to leverage, or how we could leverage this for our realization of application requirements. Talking a little bit about the benefits of operators. When looking at OpenShift Container Platform and what we can offer with an operator model, operators have repeatability of installation and upgrade. When you give a certain input as an app team or as a platform maintainer, it's very predictable what you'll get in terms of installation, or how we get from version 2 to 3, say, of an operator. We can also manage these operator upgrades from the platform perspective and really take this out of the hands of application developers if we need to, meaning seamless upgrades, again, from version to version. The operator model has the idea of health checks and observability built into it, so we can observe how our operators are being used, what custom resources are being created on the platform, what is the current state of these custom resources, and then build auditing and reporting based off that. And the last thing being, the operator framework is a great way to encapsulate domain expertise. If you can use the operator framework, either writing code in Ansible or Go, you can effectively provide your service, quote, as a service on OpenShift. Now we're going to look at some of the ways we thought of operator automation when it came to brokering services in OpenShift. And the first very straightforward, simple example is that we have a single input and single output. Again, the operator has this controller logic we see in the blue box here that's always looking for custom resources that are being created or updated on the Kubernetes API. And so when it sees this custom resource created, the operator controller will see this and then take some action based off what it sees. And again, this can work with state as well. So if we are changing the custom resource, it can, again, change the output of that managed resource over time. Next example of this kind of way of thinking about brokerage services is kind of a dual approach, or it could actually be more than two as well. But really taking a single input and sending this off to multiple operator controllers that can then do their own separate automation of dependent resources. A good example of this is a DNS host name for, say, an application. There's a lot of information that we can gather from the ingress that an application expects when deploying to OpenShift. And some things we can automate for the app team would be, obviously we need to set up ingress for the app, so how clients are reaching the containers for that application. We can also automate certificates for the application to ensure that traffic is using TLS properly. We can also automate specific monitoring of, say, the ingress or route that's associated to the application. And again, these are decisions we can make on the application's behalf, so they don't have to, go set this up on their own, kind of figure out their own solution here. The third operator model we'll look at is kind of a chained approach. So the output, say, one managed resource from one operator controller can then be fed to another operator controller that then again makes some secondary dependent resource here. And instead of explaining that further, I'll show a simple example of how an example that we see in the core Kubernetes API. Now, if you're familiar with Kubernetes, you're probably familiar with the deployment resource, which generally is used for application. It's a pod controller example, the main one that applications use. Generally, you're setting your number of replicas, the container image you want to deploy. This information gets fed to a controller in Kubernetes that then creates a replica set object. This replica set has additional, the information it needs to deploy a certain number of containers related to that application. The replica set actually gets fed to a secondary controller that then actually creates your pod resources. So this is a chained approach of automation that we already see in the core Kubernetes API. And we can take this model and, again, use it for more complex brokering of services. And the last model we'll look at is management of external services, things that don't exist in the Kubernetes or OpenShift API. And a good example of this is within Red Hat IT. We use vendors for some of our monitoring services like synthetic checks and ping monitors. These don't necessarily exist on the cluster in which the application is running, but that doesn't mean that the application can't create these ping monitors directly from our OpenShift-based platform. And so if, say, a team creates a monitor object in the OpenShift API, we can use an operator controller to automate an external service that a separate API that exists with maybe one of our vendors. Essentially, if the service has an API that's understandable to the developer of the operator, we can create an operator to manage that automation on cluster. So we've taken a look at kind of 4 different models for thinking about operator automation. Going back to that first diagram we showed of all the things that an enterprise application has to actually set up, which was much more than just the container deployment, we can start to think about how we can automate and broker the different components of an enterprise application directly from the managed platform, in this case for Red Hat IT, but OpenShift Container Platform in general, perhaps for your use case. And so looking back to the custom resource output that Tom mentioned earlier, that's on the left here, we have the entire definition for the dependencies and services that it takes to run an enterprise application. We can feed that to our, what we're calling in this case, the Uber operator, effectively the operator that then creates dependent custom resources. And this can go out and again talk to the separate components that have their domain expertise, how of how to manage, say, DNS or a database or monitoring or logging integration, those types of things. And then looking at the separate components here, those can then take on those custom resources that maybe are we'll use database as an example. We've created a database custom resource. The database operator then can see that and say, oh, I need to create a Mongo database in this case because the application requested it as a dependency of its deployment. So let's show some of this in action. First example you see here is we're actually creating that, quote, Uber custom resource that gets fed to that Uber operator. This is the high-level application definition that tells us everything the application needs to deploy and go out and manage. You can see some of that YAML up above my terminal there. And I've actually created this using a simple OC create command. And if I'm showing the UI on the right and the CLI on the left, if we start to look at what's created in this namespace, we're starting to automate the creation of a lot of things. You can see that there's a deployment that's created, a service, a route. These are pretty standard items that we would expect. But you can also see that, oh, the operator automation saw that there was a database custom resource that was created. So I need to go out and create a Mongo database. And so we're starting to spider out and create all the dependent resources that are needed for this application to actually function and do what it needs to do. The next example we'll look at here is creating an external service using a operator logic. So within Red Hat IT, we rely on New Relic for some of our synthetic monitoring. And you can see on the CLI, I actually have created a custom resource called a New Relic monitor. The name in this case being cool app-monitor. And if I look on the right, this is going a little quickly, but you can see that I've refreshed the page and the operator logic has actually taken that information from the OpenShift API, gone out to New Relic and created a synthetic monitor for my application. As part of this custom resource, I can also define labels or maybe other metadata that should be associated to the synthetic monitor. And again, when I refresh the page on the New Relic side, you can see that some of those labels actually came from the custom resource on the OpenShift side. The last example we'll look at is the lifecycle management that we can rely on with an operator model. So generally, when you deploy, say, a template object in OpenShift, you won't get updates unless you continually apply that template. And there isn't quite the understanding of how all the resources depend on each other. But with our Uber operator and additionally the operator controller logic, it can manage the entire lifecycle of our custom resources and then those dependent managed resources after the fact. You can see in this case, I'm actually deleting my Pathfinder object. That's what we call that Uber custom resource. And I'm showing on the New Relic side that my automation has detected that the New Relic monitor custom resource has been deleted. And so the operator is going to go out to New Relic and actually delete that synthetic check. This can be great for application retirement, or perhaps if we're testing an application, we're really getting full lifecycle management of the entirety of the enterprise application. So we've covered the navigation of business requirements as it relates to application deployment. And then we've talked a little bit about the translation of those requirements into a format that can be passed around and understood as what an application actually needs. And lastly, we've looked at what it takes to realize those requirements, specifically looking at OpenShift and utilizing operators to manage automation in OpenShift. As part of this program, we certainly came to the end of it with lessons learned, and we'd like to share those at this time. When we started this project and the program associated with it, like I said earlier, we started early 2019. This probably would have been the February timeframe of 2019. And if you're up to date on your OpenShift 4 release dates, that was actually before OpenShift 4 was released. So we started this program really early on, getting excited about operators. And so one of the things that we learned is to definitely tie the technology that we were using and designing around with the support of that in the latest OpenShift product. To date, this is well supported in OpenShift, so this isn't a problem today. But when we started the program, very early on in our design of it. Second item here is we thought early on that we could manage an operator model across OpenShift 3.x and OpenShift 4.x. That turned out to be a lot of technical debt that we'd have to carry on. And so with that, we learned very quickly that this should focus on the 4.x line of OpenShift versions. From a program perspective, we relied a lot on volunteers, motivated individuals to help us build out this automation, and the operators that would manage, again, domain expertise. Definitely would recommend when you're resourcing a program like this that you get dedicated resources in order to build out this very complex automation that application developers will depend on. And another thing that we learned very quickly is that you can utilize community-driven and product-driven operators and automation. And, those would be things external to our organization. Or you can develop these operators internally, again, being internal to our organization. And there's trade-offs for doing that. We very much like to be open where we can, but sometimes getting those merge requests built into the upstream code would be slow, and we'd have to kind of work with a larger community in doing that work. Again, probably the right thing to do, but at the speed in which we wanted to move, sometimes we had to carry forks internally while we were working on getting some of these merge requests in. It was very useful to separate the program based on the navigation of business requirements and then the realization of those requirements. We found that we could deliver value in both areas separately. Tom mentioned the Pathfinder application, and I've talked a lot about operators. We were able to move those independently forward, and we had our own successes and lessons learned kind of attributed to both of those development processes. But it was certainly useful to kind of break it apart in that sense and have a translatable model for that application requirements package in the custom resource that we could then act on as kind of an intermediate step. And the last item here, when we started this program, we kind of built our own business process automation. There's certainly tools that can be used today with vendors that you could simply pick up as a software as a solutions and use to solve for this business process automation. With that, we've come to the end of our session on IT brokering. There's a lot of useful information we gained from trying out a new way of automating IT requirements within our organization. And I hope that this information is helpful for thinking about transformations that can occur in your own organization. On behalf of Ryan, Tom, and myself, thanks for attending our session.